Hi, today we're going to look at integration by substitution. Now, this is very simple to do. In a problem like this, we're going to take the integral from 0 to 1 of x times x squared plus 2 cubed. We know how to integrate this. Like if I didn't have the 0 to 1 there, we know we would have to use u substitution. And of course the u in this case is going to be the inside because the derivative of x squared is 2x. It's going to cancel with my x on the outside here. So we're going to let our u equal x squared plus 2, and its derivative becomes 2x dx. So we get dx equals du over 2x, and I put that back in. We get x times u cubed du over 2x. And of course, like we said, those x's will cancel. And when we get our answer here, we're going to go from 0 to 1. This is 1/2 u cubed. And if I integrate this, we're going to get 1/8 u to the 4th. And we're going to evaluate that from 0 to 1. Now, at this point right here, we replace. We have to put our u back in. And we're going to go from 0 to 1, 1/8 of x squared plus 2 to the 4th. Applying the fundamental theorem, here's our FTC, f of 1 minus f of 0. And we can simplify this. If I plug the 1 in, we get 1/8 of, that becomes 1 plus 2, 3 to the 4th, minus 1/8, plug in 0, 2 to the 4th. And this is not bad to do. What's that? This becomes 81 over 4. Minus, what's 2 to the 4th? 16 over 4. And you can reduce that and simplify it if you like. You can leave it like this if you like, and that's okay on the AP2. Now, there is an alternate method to do integration by substitution. And this is really big on the AP test. And the difference occurs here. So what I'm going to do for now, I'm just going to copy down this step right here. Now notice what I'm not going to write down is my domains. If you recall, the whole purpose of u substitution was to either eliminate the x's or to replace them. For example, up here we replace the x squared plus 2 with u, and as a result, the x is canceled. In the alternate method, we're also going to change our domains right here, because right now, these domains are both in terms of x. X goes from 0 to x goes to 1. And to do that, it's very simple. Right over here, if I rewrite this, I get this 1/2 u cubed du, and what I'm going to do is I'm going to change my domain. To change the domain, I look at my first x. When x is 0, I have to replace that in terms of u. And I go up here. It's just 0 squared plus 2. 0 squared plus 2, which is 2. So I put a 2 down here. When x was 1, we get u equals 1 squared plus 2, which is 3. And if you notice, take a look up here, the 3 and the 2 right there, hopefully you kind of see why this method is kind of really nice for us. So if I integrate now, we're going to get 1/8 u to the 4th from 2 to 3. Now the big difference is, because I replace my domains in terms of u, I don't need to replace now. I don't need to put my u back in because everything's in terms of u. I can now go straight to my FTC. And what we wind up with is 1/8 times 3 to the 4th minus 1/8 times 2 to the 4th. And if you notice, I get the exact same thing. 81 over 4 minus 16 over 4. So both ways work. You just have to ask yourself, do you want to change your domain at the front, in the front end, or at the back end? We have to plug it back. We have to plug back in your x. Either way is acceptable, but in the long run, most people do find the alternate method a little simpler to work with. So let's take a look at another example. For example, a sine function. Let's go from, let's say, from pi over 12 to pi over 6. And we want to do, let's say, the sine of 3x dx. So again, I'm going to use u substitution. U equals 3x, du is 3 dx, dx du over 3. And I can just substitute back in. I'm going to substitute in. Now notice, I am not going to change my domain just yet. This becomes sine of u du over 3. And I can rewrite that as the sine of u, whoops, excuse me, let me write that again, as the integral of 1/3 the sine of u du. And now what I'm going to do is I'm going to change my domain. See, I want these to be in terms of u as well. So for my domain, when x is pi over 12, we know that u becomes 3 times pi over 12, which is pi over 4. When x is pi over 6, u becomes 3 times pi over 6, which is pi over 2. And those are what I plug in. So from pi over 4 to pi over 2. And I can integrate this now. We're going to get from pi over 4 to pi over 2, 1/3 the negative cosine of u. And again, because I changed my domain, I don't have to plug my u back in. Now here's the thing. If you want to replace your u here, you don't use your new domain. Either way, give you the same answer. So we get f of pi over 2 minus f of pi over 4, and I just plug in everything. Negative 1/3, and I could do this in my head. The cosine of pi over 2 is 0, minus, this is negative 1/3, and the cosine of pi over 4, root 2 over 2. And what we get? The square root of 2 over 6. And there's your area under the curve. Alright, so that is integration by substitution. Okay, if you have any questions, feel free, text me, message me, okay? Bye.